So today we're going to be solving Leetcode question 11, container with most water. So the prompt says you are given an integer array height of length n. There are n vertical lines drawn such that two endpoints of the ith line are I and 0 and I and height I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. So at first glance at the problem, any normal any normal person would try to do the naive approach, and what is a naive approach? Well, naive approach is to just simply have a pointer here, I, and then go through every possible uh pair of heights and try to find the largest container. And so what would that look like? So first we'd have an I here, and then we'd have a J that would start at the pointer I plus 1, at the index I plus 1, and every time we'll calculate the distance between here, find find the container area, keep track of the largest container we faced so far, move on, come and keep doing this over and over again until we've iterated j all the way to the end. At which case we would then move I to the next index and then repeat the process again of having j resetting another j and trying to find the largest container. Now, the issue with that approach is that you'd be getting a very bad time complexity. The time complexity you'd be getting is of this approach would be O of n squared, and if you were to give this solution to any interviewer, they would be expecting you to optimize on it. So, what is one way we can essentially optimize on this? Well, one way we can essentially optimize on this is by doing the two-pointer approach. And how does a two-pointer approach work? So we have I here, we have one pointer here and one pointer here. So our two-pointer approach, so essentially we should first start off with how do we exactly calculate the area of a container? Well, we calculate the area of a container by finding the distance between our start point and our end point, and then taking the minimum height. So in this case, our start point is 1 and our end point is 7, and the minimum and the space between these two indexes is 8, and then the minimum is 1. So 8 times 1, the area of 8 times 1 is just equal to 8. So the area here would be 8. And that's how we calculate the container area. Now, when we're doing this two-pointer approach, the thing we have to find out is how or when do we move our pointers? Well, there's three cases. Case one is height I is less than height j. In this case, we increment I by 1. We have case 2, which in this case, height I is greater than height j. And in this case, we increment j, or we decrement j. So, before I go on to the third case, let me actually go through why it's important to increment these pointers in such a way that we do. So if you look at the pattern here, we're essentially incrementing the pointer with the smaller height. And right now I will be going through the reason why. So let's say in this case we see that we get a container size of 8, right? And now we want to increment our pointers. Well, let's say let's say we, instead of incrementing the pointer that has the smaller height, we increment the pointer that has a larger height. So if we increment the pointer that has a larger height, we run into three cases. I'm going to write these cases in red. Case 1, uh, smaller height. Smaller height uh, than height I. And actually, I'll just write this as height of j minus 1. J minus 1 is smaller than height of I. Now for this case, let's just assume that there is a smaller value than 1, an integer smaller value than 1, um, just to make our case more understandable. Now, if this was the case, we find a height. It's possible if we decrement j and we find a height such that the height at j is smaller than height I. Well, in this case, our container has gotten smaller. Our container area has gotten smaller than the previous one. Why? Because not only has our minimum height gotten smaller, but also our our the width of the container has gotten smaller. So this will result in smaller container. Now let's move on to case 2. Case 2, we get height j minus 1 is bigger than height of I. Well, this at first glance might seem like a great thing, a great thing that we want, because the height at j minus 1 is bigger. But remember, the way we calculate our container size is by taking the minimum height between the two, and then taking the width or the distance between each start and end point. In this case, not only has our width gotten smaller, but also our container our start and end point minimum is still the same. So in this case, overall, we have gotten a smaller container. Now case 3 is where height j minus 1 is equal to height I. In this case, our width got smaller, and we have the same minimum. So technically, case 2 and case 3 can be put into the same case, and which just means we have a smaller container. And due to this, when we increment the pointer, that essentially has the bigger height, in no possible case do we get a container that is bigger. It's just not possible. However, and now let's go through the cases of incrementing the pointer with the smaller height. However, there are cases when we let's write this down. Increment pointer with smaller height. When we increment the pointer with the smaller height, it is possible that we get a case where our container gets bigger. So let's look at let's look at the cases where we increment our pointer with the smaller height. So if we increment the pointer with the smaller height, case 1, we get that height I plus 1 is uh is bigger than height j. So if this is the case, and let's say again height, for example, I is equal to height I is equal to 1, was equal to 1, or height I is the smaller value, and in the previous case height j was the in both situations we're talking about height I being the smaller value and height j being the bigger value. But yeah, let's just say in this case we increment the pointer with the smaller height, and we increment I. So if we increment I and we see that I plus 1 is greater than height j, well, even though our width got smaller, the width of the container, our container height has gotten bigger. So now our previous maximum height, which was our maximum for the previous iteration, or for the previous calculation, is now our minimum. And if our previous height was at least 1 bigger than the previous minimum, and since it's 1 bigger than the previous minimum, and we've decreased the width by at least 1, then this height will be at least greater than 2. This height will be at least greater than 1 than our previous minimum, and since we increased our since we decreased our width, we will get a bigger container. Or at least a bigger container. It might be the same size, but we have a higher chance of getting a bigger container. Now, case 2, height I plus 1 is less than height of j. Now, in this case, we essentially don't get a bigger container. We don't get a bigger container per se, because now we have a new minimum and our width gotten smaller. So this doesn't really help us. Case 3, height I plus 1 is equal to height of j. In this case as well, we can get a bigger container, or at least a bigger size container. Why? Because even though our width increased, our minimum height has increased. Even though our width has decreased, our minimum height has increased. Because remember, we're incrementing the pointer that has the minimum height, and now that minimum height pointer is equal to our previous maximum. So if we've increased our height, but our container size has gotten smaller by 1. So our container size is at least bigger than the previous one. So this is another possibility where we can get a bigger container. So as you see, in the two cases where we increment the smaller pointer, it's possible that in case 1 and case 3 we get a bigger container. But in none of the cases where we increment the pointer with the bigger height do we get um, any sort of container that has a bigger area, which is why it's always optimal to increment uh, the smaller height pointer. So now let's just go through the actual example. Let's go through an actual example. So let's go 1, 3, 7, 5, 4, 7, 8. So this is just an example that I made up. And let's first start here, I and j. So first I, j, 0, 1, 2, 3, 4, 5, 6. 0 minus 6, 6. Minimum is 1. 6 times 1 is 6. Move on. We see that our I is smaller compared to the j, so we increment our I and we push it here, and our j is still here. Now we this is 5, size 5. 5 times 3, 15. We get 15. Our I is again smaller, so we move it here. I, j again are right here. This is size 4. 4 times 7, 28. And then move our pointer again. I pointer again because it's a smaller pointer. And then we get 8 times, and our current best is 28. It's 15 here, and it was 6 here, but now it's 28. The distance is 3, and 3 times 5 is 15. This is in this iteration it's 15. 15 is not better than our global max. Keep going forward. And then we see that the container size here is 2 times 4, 8. It does not beat our global max, which is 28. Keep moving forward. Not 8 times, 1 times 7. It's 7 here. However, our global max is 28. So yeah, as you can see, for this example it worked, and if we even do the naive approach, we'll see that the answer comes out to 28 as well. And yeah, now let's move on to the coding section of the video. Since we're doing the two-pointer approach, let's first start with initializing our pointers. So our left pointer is going to be at 0. Our right pointer is going to be at length of height minus 1. Essentially, we're going to be initializing at the last index. And then we're going to be, let's do this with a while loop. Our exit condition for the while loop will be such that left and right should be equal to each other when they exit. So, and we should also have a best global max, and we'll set this to math.infinity or negative infinity. So area will be equal to, so we'll first calculate the area of our current start and end point. So our area of our current start and end point will be right minus left times the minimum of the height left and height right. And then we'll compare this with our best answer. So max, best ans, and area. And now this is the point where we write our three cases. So first case is where height, the left is smaller than the right. And in this case, we increment the left. And remember, if the right is smaller, we can increment the right. And if in the last case, if the left and right are equal, we can increment either. So I'm just gonna squish those two cases together. So, or not, not increment. We can decrement. So if right is smaller, in this case, if right is smaller, this would be if height of left is greater than or equal to height of right. If the right endpoint is smaller, then we decrement it, and if it's also equal, we decrement it as well. So I just squish those two cases together, and then eventually we return the best answer or the global answer. Let's run it. These two cases. Okay, it passes. Now let's submit. Okay, so yeah, that is the container with most water question. If anyone has any questions, please let me know in the comments. And yeah, till next time.